Hello everyone, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungudi, MSc MPhil Mathematics, your math tutor from CD King Higher Secondary School, Science Stream, Jotsama, Kohima. In this session, we are going to learn some practical problems on sets, how to solve some practical problems using sets. Before that, we need this formula. Please have a look on it. Let A and B be finite sets. We have already learned what is a finite set. Finite set means either empty or countable number of elements in the set, right? So that is finite set. So it should be empty or countable number of sets, number of elements in the set. Those are called finite sets. Then n of A union B equal to n of A plus n of B minus n of A intersection B. I'm not going to show the proof here. I'm leaving it to you. It is very simple. If you go through the textbook, you can find it. And n of A union B equal to n of A plus minus n of A intersection B. See, I'll just show the Venn diagram for this. This is set A, set B, U. So union B is everything, right? All the elements here A and B. So when we take n of A is this one. Then n of B again. If you see this portion, I have included already with A when I counted this number of elements in A. So we cannot include those elements here when we count the number of elements in B. That's why we are subtracting this minus n of A intersection B. Suppose if A and B are disjoint sets if they don't have any common elements. So two separate circles like this, they don't have any common elements. That means number of elements in the intersection will be 0 because it's an empty set, right? So it will be 0. Therefore, if you put this one 0, you get this formula. N of A union B equal to n of A plus n of B. Then this is the extension of the first one using three sets. N of A union B union C equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus A intersection C and n of plus n of A intersection B intersection C. This we will be using it for our exercise problems. And these three, it is not in your textbook, but it is very useful to solve many problems. So please take note of it. N of A minus B plus n of A intersection B equal to n of A. You see here, if you take the Venn diagram, this is A, B, and this is the universal set. N of A minus B is this one, the number of elements in this area, isn't it? Okay. Then A intersection B. Intersection B is this portion. If you add these two, we will get the number of elements in set A. That's why we write n of A minus B plus n of A intersection B equal to n of A. N of A intersection B means number of elements in A intersection B. This is called cardinal number or cardinality. And similarly, we can write this n of B minus A plus n of A intersection B will be equal to n of B. The last one is, if you add n of A minus B and intersection B and B minus A, we get A union B. Already we have seen that A minus B, A intersection B and B minus A are disjoint sets, mutually disjoint sets. So when you add all together, you will get A union B. That is like this. This is A minus B and this is intersection B and this is B minus A. So when you add all, you will get the union of A and B. So that's all. Then we will move on to the exercise problems. Okay. Here we will go with this question. In a group of 70 people, 37 like coffee. 70 people, in a group of 70 people, 37 like coffee and 52 like tea. And one more thing, and each person likes at least one of the two drinks. At least. We have already seen this. At least means it represents the union, isn't it? Okay. And how many people like both coffee and tea? Both represent the intersection. Both represent the intersection. Union, each person likes each person in the group. There are 70 people. That is, the union of coffee and tea will give you 70. And you have to find out the intersection of these two sets. So let us assume n of t is the number of persons like t, that is 52, and n of c for coffee. So number of persons like coffee is 37, and also what is given? N of t union c, at least one drink, tea or coffee. So that is 70. And our aim is to find out n of t intersection c. How many of them like both tea and coffee? So this we have to find out. So this is by the first formula, that is n of t union c is equal to n of t plus n of c minus n of t intersection c. Right? See, this formula we will be using it in the probability also. That is the last chapter in your textbook. So the same formula we will be changing it into probability of t union c equal to probability of t plus probability of c minus probability of t intersection c. So here substitute the values. This is 70 and n of t is 52, n of c is 37 minus n of t intersection c, which we are going to find out. So I'll bring this n of t intersection c this side and take this 70 other side. So we get n of t intersection c will be, if you add these two, you will get 89 minus 70. So it will be n of t intersection c will be 19. So 19 of them like both tea and coffee. That's all. The next problem is, it's a very important type of this kind. Every year you can find it one in your question paper. It used to come for 6 mark question. Even in competitive exams you will find this type of questions. In a group of athletic teams of a public school in New Delhi, 18 are in basketball team, 25 are in the cricket team, and 22 are in the football team. There are 3 teams. The first one is basketball, and the second one is cricket, and the third one is football. So we have 3 sets, isn't it? So let us assume that one first. I'll use the first letter of each team in order to avoid the confusion. B, C, and F. B denote the set of all players who play basketball, cricket, and football, respectively. Okay. Then, if 9 of them play basketball and cricket, they can play both basket and cricket. And 10 of them, 9 play basketball and cricket, and 10 of them play cricket and football, and 8 play football and basketball. Right? There are some common players, isn't it? So if you draw the Venn diagram, you will have intersecting circles because there are some common players. So we do draw these 3 circles intersecting. So this is basketball team, and this is cricket team, and this is football team. All right? Okay. And find the total number of players in the group. How many of them are there? And the number of players who play only cricket. Okay? And given that 4 players, they play all the 3 games. So what we are going to do, we will represent the region separately. For example, this is A. If you denote this one as A, that means this region is A. This A is the number of players in this region. That means purely they play basketball. It is not in common with any of the circles, right? So those who are here, this A is the number of players who play only basketball, and this one by B. So this is the one. All right. So this is Here, those who are here, they will play only cricket. So B represents the number of players play only cricket. Similarly, this one C. This is C. Alright. And here again this portion, no? This portion D, and this is E. Okay, this portion, and this is F. And this is G. You can name it by different letters also, by different alphabets. See, D represent the players who play basketball and cricket only, right? That is here. Those who are here, this D represent the number of players who play basketball and cricket. And E represent only the cricket and the football. And F represent the number of players playing basketball and football. And what is this G? G represent the number of players who play all the three games, right? So G can play, the number of players here can play basketball, cricket and football. So we divide the regions like this: A, B, C, D, E, F and G. So you have to assume this. Let A, B, C, D, E, F, G represent the number of players in the bounded region. In the bounded region. See, for your board exam, it is compulsory to write this assumption. For competitive exam, you don't need to show all these calculations. But for board exams, it is 6-mark question, so you have to write all the steps. No jumping steps. A, B, C, D, E, F, G represent the number of players in the bounded region. Alright, let us go back to the question. 18 play basketball, right? So this is the basketball set, isn't it? Those who are here, everyone plays basketball. Even this D plays basketball, G plays basketball, right? Even though they play this cricket also, they do play basketball. So everyone here in this circle, they play basketball. All together it is 18. Therefore, as per the question, A plus D plus G plus F is 18. Is that clear? And the next one, 25 of them play cricket. That is, those who are here in this circle. That is, B plus D plus E plus G is 25. Name it as 1 and this is 2. And the third one, 22 of them play football. That is, C plus E plus F plus G is 22. Take this as equation number 3. And 9 play basketball and cricket. You have to be careful. Those who are here, this portion. Alright. So they play basketball and cricket. This D represents the number of players who play only basketball and cricket. G represents the number of players who play all the 3 games. Those who are here, they can play these 2 and additionally football. But those who are here, they play basketball and cricket only. They don't play football. This is it. Therefore, D plus G will give us 9. Then cricket and football. This is G plus E will give us 10. This is 4 and this is 5. And last one is this 2. F plus G, they play basketball and football, right? So that is 8. That is 6. And G is 4 because 4 players, they play all the 3 games. Therefore, G is 4. Okay. So using this G, if we can find all the letters A, B, C, D, E, all. So like, if you substitute G here, you will get F. F will be, already we know G is 4. Then F will be what? If you substitute G equal to 4, 8 minus 4 is 4. Then if you substitute G equal to 4, you will get E as 6. And then if you give 4 here, then D will be 5. Then if you give DGF, DGF, D is 5, 9, 13. 13 minus 18 minus 13 is 5. Therefore, A is 5. Then B will be DEG. 5, 11 and 15. 25 minus 15 is 10. And C will be EFG. E, F and G. 8, 14. So 22 minus 14 is 8. right? So if you get these values, it is easy for us to answer all the questions. We have to find out the total number of players in the group. So the total number of players in the group will be, if you add all these, A plus B plus C plus D plus E plus F plus G, so you get 42. Okay, then next, the players who play only cricket. Who play cricket only. So this is B, right? This B number of players only play only cricket. Therefore, B is 10. Therefore, 10 is the answer. So using these values, you can find out, you can answer any type of questions. So this is very important problem. It is usually asked in 6 mark in your board exam. So please take note of it. There are only few more questions in your exercise like this. Please do practice all the problems thoroughly. And if you have any queries, you can contact me at this address. And this is the end of our first chapter, sets. In the next session, we are going to learn relations and functions. Then if you have this type of problems are very, very important. Again, I am telling you, because you can easily score 6 mark. And the same problem, we can do it by using the formula also. But most of the students, they prefer this Venn diagram method. So if you are interested to learn the other method also, I will do it separately for you. Thank you.